Okay, welcome to a talk about cookies. I always get hungry when I do this talk, but it's lunch afterwards, so that's great. So I'm Anders Abel, and I work for Duende Software, where we do single sign-on solutions, and that has brought me to a kind of unhealthy relationship with cookies. Because whenever you establish a session in a web browser, you need a cookie. And with the browser vendors starting to block third-party cookies and do various more or less obvious things to how they work with cookies, I've kind of become interested in trying to understand when is it working now and where are we heading? When will it work in the future or not? So first, a bit of very basic, what is a cookie? So when a server responds with something, content or whatever, it can send along a set cookie header with contents, and whenever the web browser makes subsequent request, they will send along the cookie with that value to the server. And this is how we keep track of sessions. You know that as developers, we are usually quite privacy aware by nature, or used to be at least. So back in the 90s, this was actually a thing. A built-in cookie consent in the browser. And you could allow it, or you could allow for session only. But that turned out to be awkward because cookies are used so extensively. If you have a shopping cart, if you have anything, you need to remember the session or keep any kind of session state for a user visiting your website, you need a cookie. So the consent was removed, and these were the golden age for cookies. The cookies were free for the websites, that is. They could use cookies wherever, in whatever context, and it worked. And everyone was happy. I was surfing along on the web using an ADSL modem like this. Very simple thing. It had Wi-Fi built in, and it worked. A few admin settings, an admin panel, and some action on the server side that stored the settings if you submitted it. So one day, online, I had a security researcher I know. He asked, do I know anyone who has a signal model of this specific signal modem of this specific model? And I said, yes, I do. Like 10 seconds later, I had a PM. Hey, I created a site for you. Do you think I tested it? Of course I did, I'm curious. So I reluctantly tested it. And it was actually a page of kittens. Nice, sweet kittens. And then I thought, like, wow, it's just kittens. That can't be evil, can it? Well, it turns out that these are evil kittens. And it turns out that Leif, he didn't go all the way asking about the people he knew who had this specific modem, creating a website, sending PMs to them just to show us pages of kittens. No, no, no. Of course, there was something he wanted to do. So I checked the page source, and on the source, on this page, there was also a hidden iframe with a form that looks exactly like the changed DNS form on my modem, admin console, and a JavaScript that auto-submitted this. Now, this modem had made two assumptions on security for protecting that page. One is that the user had to be logged on, and the second one, it should be on the internal network of the user. I mean, the evil kittens, they are on the internet. Can they access the internal interface of my modem? No, not directly. But what happened here is that they are asking my computer, which is on my home network, to do the change for them. And also, as I'm a geek, of course I have logged into my modem, right? So when my browser sends this post request to the modem, it sends along my authentication session cookie. So my DNS settings were changed. And from now on, Leif didn't need any phishing mails to distract me when I went to various websites. No. He could, of course, control the DNS service and make me go to the DNS server of his choice. So this is cross-site request forgery. And this turned out to be a problem for cookies. So here we are. We are the brave developer in the middle. We protect our users from the evil hacker. But this time we got allies. The browser vendors came to help us. So when we set the cookie, we can send along a few more attributes about the cookie. We can set HTTP only to make sure that the cookie is not readable by JavaScript. You know, normally a cookie can be read or written by JavaScript executing on the page, which means that if someone brings evil JavaScript onto the page, they can get the cookie. We can set a secure flag to say that this cookie may only be submitted if the request is made over a secure connection, HTTPS. And we can now set SameSite equals strict, saying that in a cross-site scenario, such as the kittens attacking my modem, the cookie should not be sent along. Up until this, whenever the browser decided whether to send a cookie or not, it just checked the destination of the request. But now it started checking also what is the page, what is the origin of the request. So the SameSite attribute was introduced. And to be backward compatible, the default, if no SameSite attribute was sent, that cookies were allowed everywhere. And then we had strict. Sorry, that was default. And we have strict. And strict means that a cookie will only be sent on the same site. If we navigate from the same site, load a sub-resource from the same site, whatever. But this turned out to be a bit too strict. So I consider that a colleague of mine would send me a link in an instant messaging program or web app or whatever, Slack on the web. It's a link to an internal document of ours, which requires me to be signed in to view. And I am signed in on that server. But when I click the link in Slack, that is a cross-site request. So the cookie would not be sent along when I got to the document archive. So that's why Lax was introduced. And the idea with Lax is that developers always do things right? So HTTP verbs. You're always careful about them, I hope. You would never change any kind of state on a GET request. So GET options head, those are the HTTP verbs that are assumed to just fetch data. And then we have post, put, delete, etc. that are meant to alter data and alter state on the server. So the idea with Lax is that we can send the session cookies along as long as it's a request that should not alter state. And one thing with cross-site request forgery attack is that it is a blind attack. An attacker, such as the evil kittens, they can write things to my modem, but they cannot read the settings back because it's a cross-origin blocking. So this was fine. So just what is a site then? So if I have two URLs, are these the same site or not? They are the same top-level domain, example.com. So that means that as long as you're within your company realm or under .com, you are on the same site. But if you're running on various country domain, example.se, example.no, etc., that would not be the same site. What about these, though? HTTP and HTTPS, example.com. This is a trick question. There are two right answers, depending on what version of the spec you read. So they were the same site first, but then they changed their mind. So now the scheme is part of the site definition, so they are not anymore the same site. So that's simple for the .com domain, right? What about the UK? Are these should these be the same site? No. And of course they are not. Because co.uk is kind of a top root domain that you can register domain under. What about these, though? AzureWebsites.net and evilkittens.azurewebsite.net. Are they the same site? No. Sorry?
So you need a special list of...
You need a list, yeah, that's right. So it would, since Azure Websites.net is kind of open, you can register any name under it, signing up through Azure portal. We want the cross-site protection between different Azure Websites.net hosted websites. And the answer is the public suffix list. So UK has submitted a list and said, it's very small print, but co.uk is on this list, and Azure Websites.net is on the list from Microsoft. GitHub.io, blogspot.com, all sort of sites where different users or customers could create content, or could potentially create cookies, are on this list. And it's a huge list. And it will mean that we have a decent site isolation between, a decent definition of sites. You can submit to this list if you're large enough. For your hobby project, they probably won't take the pull request. It's actually maintained on GitHub, so the way you submit new entries is literally a pull request combined with setting a text record in your DNS with the pull request number, just to indicate that you are actually authorized to manage that DNS. So the browser vendors helped us. If the attacker tries to steal our cookies through cross-site scripting in JavaScript, well, HTTP-only cookies prevent that. HTTP plus sniffer, that is a downgrade attack. Imagine that I was setting, I'm communicating with the website using HTTPS, but then the hacker sends me a link with HTTP that I click or use in the cross-site in a third-party scenario or something. If the hacker then is on the same conference Wi-Fi as I am, or I mean, this is tech conference, are we even sure we are connecting to the right Wi-Fi, not in someone's rogue access point? With HTTP, the traffic would be clear text and they could sniff it. Secure flag will help. It will ensure that this cookie is never sent if it is not a secure connection, end-to-end encrypted. And cross-site request forgery, as we talked about, SameSite helps us. But that's not all. There are more weird ways to attack cookies. So one thing, if we look at the set cookie header, there's a lot of flags. When the cookie comes back to the server in a request, is there any way to know if this cookie is indeed secure, if it is indeed has a proper same-site protections? No, we are not only getting the value back. And this can be abused, of course. So consider university. They have an admin portal, the main site and an admin portal. And at the computer science department, they have an area where students may publish their own projects. So one of these student projects, they set a cookie with a domain flag, saying that this cookie should not only be sent back to the hackers.student project csabc.edu, it should be sent to any host under abc.edu. So essentially, they are now setting a cookie for another host or domain. And there is no way for poor admin.abc.edu to detect if this was actually the cookie they set themselves, or if it is a domain-wide cookie set by the students. But the browser vendors came back to help us. They introduced prefixes. So if we name our cookie with __ secure something, then there is a requirement that the cookie is also set with the secure flag. And there's an even better version, the host __ host, which requires secure, no domain, and a path. So the recommendation is for any session cookies that we use for server-side sessions, it's a good idea to use the __ host as a precaution. This was in a draft that was expired, but as far as I could find out, it's in the latest draft, so it's on this track to being. There is an updated draft with both SameSite and prefixes, and a lot of stuff on how to treat cookies, and this is in the draft. So far, the browser vendors gave us tools to help us. then Chrome looked at the SameSite feature that they introduced in 2016 and said, hey, this really slow adaptation here. And the sites that have not adapted it, that are a bit slow, are probably the ones that really need SameSite protection and might have cross forgery problems. So why not help them out? Let's move the default to none and introduce a new value, let's move the default to lax and introduce a new value of none for those that really want their cookies to be available SameSite. And they rolled this out, and things just started to break. So the problem was that everyone hurried to set their cookies to SameSite none, which meant you had to upgrade libraries, etc., to get versions of libraries that could use SameSite none and issue that, which meant that you had to upgrade, and maybe you had other reasons why you hadn't upgraded in the first place, and things were horrible. To make things even worse, remember the original spec didn't have the word none. Originally we had lax and strict, and if we wanted the cookie to be free, we just omitted the SameSite attribute altogether. And that version of the spec actually said that if it's lax, treat it as lax. If it's strict, treat it as strict. If it's an empty value non-present, treat it as none. If there's anything else, treat it as strict, secure by default. So what happened when we started pushing SameSite equals none to these old browsers? Well, they didn't recognize none, so they treated them as strict. So that's why we find this piece of code in a lot of places. If user agent contains CPU iPhone OS 12, that is iOS, Safari in iOS, and then certain versions of Mac OS X running on Intel-based processors using Safari, and certain old versions of Chrome. And I think here they made the assumption that we would not hit Chrome version 500 while this piece of code still was alive. But if you have it still around, remove it before Chrome 500 is released, because otherwise things will break. And it's now safe to remove it. I checked it out last year, and all the browsers that were affected by this are now out of support, together with their iPhone versions, etc. So it might be a way to encourage people to get off their old browsers. So far, we've looked into areas where we want to protect our cookies from being stolen by a hacker, and we want to help our users. But there are other cases as well. What about a tracking pixel? What happens here is if we have inserted this Facebook tracking pixel on our site, what happens is that when the site is loaded, it's loaded from the server, and the tracking pixel is loaded from Facebook, and any session cookies or cookies that belong to our server, sent along to our server, they are first-party cookies. It's the same domain as is displayed in the top-level address bar. But we also have third-party cookies. And this is how Facebook knows everything about what you do on the web, because there are trackers all over. The browser vendors cares about privacy, so they decided that, well, we do not only want to help our users to be protected against hackers, but also against trackers. The next problem, though, is that the browsers were our allies. They put a lot of tools to us, but they offered us the tools. This time, they are considering us part of the enemy. Why? Well, because we inserted the Google tracking script in the first place on the site, right? So this is where the first-party site tries to do things, and the browser vendors wants to help us against it. So what I will just show you is an example of what happens when we are starting to block third-party cookies. So I'm bringing up, let's see here, Chrome. I'm bringing up an incognito version of Chrome. I'm not cool enough to have a Mac. I'm sure that Dominic Bayer will buy anyone a beer that managed to convince me to change to Mac, because I tried all the 2 days of workshop to make me change, but I'm not switching. So if I try here, I'm using Chrome here with third-party cookie blocking enabled. I go to teams.microsoft.com. Teams redirect us to Azure AD, where I do sign in. And I enter my password. And I, of course, have two-factor authentication, and I didn't switch it off just for the sake of the demo. I don't trust people. 23, yes, it's me. And Teams, let's click on that. Oh, hey, why is my mouse only on this screen? Yeah, let's click on that. I want to keep signed in. And we load Teams. And Teams starts. It starts. It says I should get the Windows app. It starts. If you want to open the web app, please change the settings for your browser to allow cookies. So when I have third-party cookie blocking enabled, Teams doesn't work anymore. And why is that? Well, it's because Teams is employing a very similar technology. To be able to do single sign-out and token renewal, it uses a small hidden iframe that renders something from Azure AD. And that is a third-party cookie context. And when the cookies cannot be detected here, Teams thinks, oh, he signed out of Azure AD. He immediately started Teams just to hit sign out over at the other place. So it essentially detects you are signed out. And then Microsoft added a detection for this, where they want, with this error message, originally this just kept spinning. It kept trying over and over again. So to a browser, there's really no difference between the legitimate single sign-on session and a third-party tracker. In both cases, what we are trying to do is to track a user across different sites, right? And I'm sure if they made an exemption for the OpenID Connect protocol for detecting this is exactly OpenID Connect, what would happen? Well, the ad companies would start using OpenID Connect to track the users. Another place where iframes and third-party contexts are used is on front channel logout in OpenID Connect. So this is the ident server. We have the page you are now logged out, which is kind of true. By the time I read it, I am probably logged out. But it could also say you are now being logged out, because on this page there are hidden iframes that call the logout endpoints of my client applications and indicate to them that now it's time to log out. If they cannot handle cookies here, what will happen is that identity server logs out, the identity provider, but client applications remain signed in. And that is, in my opinion, a really bad thing, because if I am signed in, I click log out and hand my computer over to someone else, I now trust that I did log out, didn't I? So that other person should not be able to get into my applications. So let's get into what different browsers are doing. We already see Safari, talked about Safari. If we have shopping.com is using cloudlogin.com. If the user tries to access shopping.com, the cookies from cloudlogin.com is not allowed in a third-party context. But are they always blocked? No. Let's see another user coming in, because they've been to cloudlogin.com first. They've been there doing something, clicking on something. So that domain has been marked as a domain that the user likes, a domain that the user interacts with. Then it's perfectly fine. Great for help desk, service desk calls, right? Okay, but this is at least predictable. You can instruct them, the users, what to do. But Safari also has intelligent tracking prevention, and yes, you're right, it's AI. Intelligent tracking prevention works by checking if we have a number of sites, loading resources from another site, or we have a huge number of sites loading resources from a site. It actually tracks for each of these right-hand sites the number of different domain it serves sub-resources to, the number of different domains or sites that it serves iframes to, and also top-level redirect, which is called bounce tracking. When third-party cookies embedded in an iframe and other requests that are not intrusive to the user didn't work, Tracker started to do a quick redirect, just over to Tracker and back. And they also blocking that. Well, that is kind of single sign-on, isn't it? If we are already signed on, we are redirected back to the identity provider, assumes that it should detect our existing session and redirecting back, it breaks. They also have something, and if the AI, based on these facts, classifies your site as being a tracker, they put your cookies in the bin, and all other local storage, web data, whatever. There's also another evil thing they can do. Because as a tracker, I've set my cookies to SameSite none, of course. They can change that for you to strict. So you get to keep your cookies, but they now are no longer sent along. So I think this is quite horrible for SSO, especially the intelligent part, which means that it's not obvious, it's not consistent. Different users will, based on different behavior in the past, have different classification of the same solution. And you as developers will probably have a vastly different interaction pattern with your site than the end users have. But we're not done with Safari yet. Let's talk CNAME cloaking. So this is a new feature in Safari. Safari 16.4 was released in April this year. And they didn't include this in the release statement or so, but there is a pull request you can find where it lists some of the details, and then people have gone into the code and go into testing to find out what is actually the blocking that is happening. So CNAME cloaking is Safari's effort to try to block this, that shopping.com uses tracker.com. So to be able to let the tracker.com server set cookies, we can have tracker.shopping.com as a CNAME to tracker.com. Of course, this cookie will be bound to shopping.com. It's not a CNAME cloaked cookie would be different from tracker.diamonds.com, tracker.shoes.com. Those would be distinct different cookies, but it's still a way that allows the tracker.com host to set cookies in the user's browser. Safari wanted to block that. So what they do is they are actually checking if tracker.shopping.com is a CNAME and it resolves to another top-level domain that shopping.com, if that has a CNAME, does, and says that, oh, even though tracker.shopping.com should be first-party based on the name, we see it's just a cloak for tracker.com and we'll block it. So what was the immediate response to this CNAME cloaking? Of course, skip the CNAME, go for IP address. Set up an A record, right? And what was Safari's response now in April? Check the IP number. If the first two octets of the IP number are different, they treat it as a different site. So for any one of you that might be using different hosting providers for different part of your application, or just the same provider but two different IP ranges, you might now get your cookies blocked even if it's the same site scenario. My head hurts. And I mean, to me, this is the most invasive thing, because apart from this, cookies are reliable and works in a first-party context. But this is breaking legitimate first-party applications. Over to Firefox. So if we have two shopping sites, shoes.com and diamonds.com, then they are both using the Facebook pixel, and both are making requests to the facebook.com domain, and the cookies are there, so it means that when shoes.com makes the first request, a cookie is created. When diamonds.com does the next request, Facebook can detect, we already have a cookie here, so the same user is looking for both shoes and diamonds. Great news. So what Firefox decided to do was not to totally block the cookies, but to create different cookie jars. So they now have different cookie containers based on the first-party domain. So if shoes.com accesses some resource, a tracker at Facebook, there will be a cookie set. But that is in a different cookie container to when diamonds.com does the same. So depending on what first-party website you use, they might be different. And this is just great news for single sign-on, because on different sites, when we query the session state of the same identity provider, we will get different responses. Great, isn't it? But I think that Safari, they actually, or Firefox, they helped it out a bit. So let's try the Teams thing in Firefox as well. And I'll do it in a private window, teams.microsoft.com. And they are actually asking, allow login microsoftonline.com to use its cookies on teams.microsoft.com. That kind of makes sense to me. Does it make sense to you, that request? Allow login.microsoftonline.com to use its cookies on teams.microsoft.com. You may want to block access if it is not clear why login microsoftonline.com needs this data. Would that be clear to all your users? No. So people will be blocking. I actually think this is quite fine for Firefox, because Firefox is kind of a geek browser, which means that I think that most people using Firefox, out of the Firefox user base, most users would make sense of that. But for a larger browser, probably not. So let's see what the different browsers do. Safari. As we've shown, they are blocking aggressively. What are Safari or Apple making money from? I'm a bit of conspiracy theorist here. They're selling devices. They are even plugging privacy as a feature of their devices. What is Firefox making money from? Well, it's a non-profit organization. So they can pull the plug for third-party cookies. Edge. What are Edge making money from? They are the embedded browser in Windows, which is Microsoft's way to say that if nothing else works, have you tried Edge? So Edge will not do anything before Teams get their shit together. What about Chrome? What is Google making revenue from? Ads. So the conspiracy theorist in me would say that the reason that Chrome is reluctant blocking third-party cookies is because of their revenue. I saw some numbers that they tried third-party cookie blockings, and they estimated that they would be losing about 60% of the revenue. But there's also another thing, and that is responsibility. Because if, for the duration of the internet, there's been multiple browsers, and all the time there's been one go-to browser. Remember back 25 years ago, or 20 years ago, if a site didn't work, have you tried Internet Explorer? Internet Explorer was the go-to site. It was actually, for a few years, it was actually a good one. Today, Chrome is the go-to browser. which means that if Firefox breaks things, the user likely has Chrome as a backup. But if Chrome breaks things, things really break. They have the majority of the market. And they are kind of burned because remember, they changed the default setting of the cookies to help those sites that still had not enabled SameSite attributes. And of course, in tech companies, we were fast moving, we had adopted that. It might have been one or two tech companies that did it in a hurry when it was announced, but we had. There is another sector in the society that maybe not is that fast moving, and that is the health sector. So actually, Google rolled this out in the early 2020. And early 2020, I don't know if you remember, there was another thing rolling out over the world at the same time. COVID-19. And this was a really, really bad timing to break healthcare sites. So I think Chrome did the responsible thing to roll back the SameSite default changes at this time, because it was critical to have things working at this time. So there are two reasons. Be a conspiracy theorist and think about revenue if you want. Think responsibility. I'll be nice and say that Google are a responsible company. But nevertheless, they are planning to phase out third-party cookies. And in 2020, they communicated it would be done in 2022. Hey, this is 90 project. So in 2021, they communicated it would be done in 2023. Guess what? It's a 90 project. In 2022, they communicated it would be done in 2024. And now in 2023, just a few days ago, they communicated that it will be done in 2024. Early 2024 even, for 1% of all the users. But I think this is really being careful. Roll the new default settings out for just 1% of the users. But that means early next year, you will get spurious support calls from people having odd problems because the third-party cookies are blocked in Chrome. What about the ads then? Well, of course, Google has tried hard to find something, and the UK privacy authorities have really been pushy to Google, and they have introduced a concept called privacy sandbox. And I think this is good because Google has really taken the steps to figure out, okay, with third-party cookie blocking, what features are we breaking? And they are also trying to find a middle ground for tracking, because now it's so easy to just track an individual user. But in reality, are they interested in if I am looking for a new car or bike? No. What they are interested in is that if I've been visiting a bike online reseller, they want to show me online ads for bikes on other pages that I visit. And the targeting works. I actually read my morning newspaper online 2 weeks ago and woke up, scrolled down a bit, and got a big picture of Dominic Bayer because it was an NDC ad in my newspaper online. If it was a good thing, of course, Dominic, it was a good thing to have a picture of you to wake up with. But what they want is a way to convey that, well, this person is interested in bikes, but without telling who it is. But when I read up on this, I found out there are also other things they do. One is a trust token. Because one thing that the ad networks obviously has to care about a lot is fraud. Fraudulent click records. So there are bot networks out there that can simulate clicks on ads to get money, or make someone else burn money, or whatever. And to prevent that, one of the use for trackers is trustworthiness. So on my computer, I assume there is a cookie now that indicates that this computer is actually used by a human being. So any clicks on ads done by this device is a real click that should cost money. And to convey that kind of information, they've invented some trust token framework where they let sites communicate that this is a trustworthy person, but without offering any kind of possibilities for the site to transmit data between them. And they also list on their site, what are we breaking? OpenID Connect front channel logout, OpenID Connect session management, that is Teams, iframe-based token, background token renewal, iframe-based login widgets. So they know what they are breaking. One thing I think will also break is the federation gateway pattern. Unfortunately, because it's a great pattern for single sign-on. So consider if we have a number of client applications that are connecting to a login server. This is a common pattern. And as we've seen, as long as the user interacts with the login server, this will work. But a common pattern is that there are two login servers. There is the actual login server for the user, Azure AD or whatever, where they sign in. And then we have an internal token server that is just our source of authority for our APIs, etc., a federation gateway. But that is hidden. There is no user interaction ever on that site. So when a user comes in here and interacts with a client application and the far and real user directory, there should be cookies set on all three levels, but I think the cookies will be blocked in the middle. And that's unfortunate. But Google has thought of this as well. So they are introducing Federated Credential Management API. So what is that? Well, have you seen this sign in to my example app with Google that is an overlay on your application or some applications? It comes up. And even without me having given any kind of consent to the site to read my Google sign-in state, it knows that I'm Anders. I think this looks very much the same. I also think that it looks a bit too much the same when we are talking about the UI. Here, the browser is taking over the UI. Will we be able to, or that is what I can see in the demo here. So I'm concerned now, will we be able to do rich UI, customized UI? And what we see at Duende is that for consumer-facing websites, signing on or creating an account is part of the onboarding process of a customer. And it is a lot of effort is often put into making that a low-friction process. We gather the right information at the right place, probably when the user already placed our things in the shopping cart, to know that they are kind of committed. So I really hoped when I was researching for this talk that I would be able to give a definitive answer on what will happen, but unfortunately I'm not. The Privacy Sandbox API will be released in preview this summer. I will, of course, look at it, and especially for Federated Credential Management API. It is also very interesting to see what will the other browser vendors do. This is a Google initiative, the entire Privacy Sandbox. They try to tout it as an industry-wide initiative, but it is indeed Google. I've not seen interest from Safari really to join yet. We are maybe once more back to user agent sniffing. So what are my conclusions really about cookies? Well, first, I think that we should consider from now on that cookies are first party. They are first party concept. Any third party context where we rely on cookies will be unreliable. If you're an ad network building a tracker, well, go for it. If you can track 80% of your users, that's at least 80% tracked. The 20%, well, you might lose a bit of money. But from a security standpoint and single sign-on, this is awkward. We cannot have 80% security. We cannot have 80% success rate on hitting the logout button. and in 20% of the cases, the user is still logged on without knowing about it. No, we need 100% success rate. So single sign-on, I think that for now, if you have interaction on each host that sets a cookie, it will continue working. And especially within a SameSite scenario. But I think that the wider cross-site single sign-on solutions, I don't know what will happen with them. And this includes cloud providers such as Azure AD. I have no idea what will happen to them. Maybe we'll have, sorry, you have to use Edge. I mean, that's a possibility. Because the browser vendors are not in sync here. And they, as we saw, they have different interests in what they want to do. And we have single logout. Well, front channel single logout, where we use the hidden iframe, is dead. It is not reliable anymore. We need to do back channel calls, which means we need to keep track of the sessions on the server side to be able to see this. So I really hoped that I would have a lot of answers here at the end of the talk, but I think that I might leave you with more questions about the future, because my crystal ball didn't work that well. But I'm open for questions. Or if you're just eager, yeah?
Can you comment on the Brave browser?
Comment on the Brave browser. The Brave browser is privacy aware. It blocks much more than anyone else. I didn't include it here because it is such a niche browser. So the browsers I included here are the top 4 ones used according to the current statistics. I do not personally use Brave, so I cannot say how much things work or break with it. I don't know, Dominic, I know you're a Brave fan. Do you have any comment?
Teams doesn't work on Brave, yeah?
Teams doesn't work on Brave. Of course not.
But yeah, Brave is a great browser, but yes, it basically does all the things that you described a little bit earlier than the others.
Yeah. So I'll just read.
It works, yeah?
It mostly works, and it also does all the things that I described, but a bit earlier than the other. It's an early adopter. But it doesn't do intelligent tracking prevention and these A-record things. That is actually what scares me most, these kind of fuzzy rules that we cannot really have a reliable way to detect up front. Yes, at the back. How about SAML 2 authentication? Yes, someone asked me about SAML 2. So for you who don't know, I've been working with SAML 2 and developed and maintains a popular open source library for SAML 2. So actually, the original SAML 2 specification didn't use iframes for logout, but bounce redirect. And I recently was in a project where we used that. We couldn't make the iframe. There are a lot of SAML implementations that have moved to doing the logout in a hidden iframe, even though that's not how it is described in the original spec. But I was recently in a project where we moved over to the original way. We are bouncing to the logout endpoint. But that, on the other hand, is horribly brittle. But apart from that, the sign-on experience is very much the same as for server-side OpenID Connect application. You need interaction on the side you need to convince the browser that it's okay to set a session cookie on the identity provider before redirecting back. And long-running sessions, I didn't mention here, but there are also, or has been variants at least. That's the hard thing with this topic, is that you find a blog post that is 2 years old that describes exactly how it works, and then it turns out they changed their mind and do it another way. But they used to be, remember the splitting here of the cookies. I think Safari for some time had a concept where they could start with the common cookie jar, and then if there was no interaction on the Facebook site, they split the cookie jar by copying it. So you could have created a single sign-on session to start with, and then without you knowing it, you get two different views of the state of the same. So yeah, I don't know if I did say that is, but I think that actually SAML 2, in this case, might perform a bit better than OpenID Connect. Yes?
You're saying that single sign-on may or may not break, depending on if you have user interaction. But very often you have like a federation gateway that asks you, do you want to log on with Google, Azure?
Yep.
Then at the next time, there is no user interaction. How do we expect that to be?
So the question was, Federation Gateway here, typically we would have user interaction in the first time we go to the Federation Gateway because it asks, do you want to use Facebook or Google, or what provider do you want to use to sign on? And then it is expected to remember that through a cookie to the next time we come back. And the next time we haven't interacted with the Federation Gateway, I would simply assume that you get that question over and over again. I would simply assume in that case that if there is a UI step on the Federation Gateway letting you choose between different providers, it will have no memory, or the memory will be lost after a week or so. So as long as we have user interaction, I think the Federation Gateway pattern where we have just one upstream provider where we just bounce on it, it's an important technical piece of infrastructure, but it's not anywhere where our users interact. That is where the risk is for this breaking. But I don't know, and the only thing I can say is test it. And test with different browsers, test it with different domains. On my computer, I set up not just localhost, I have other hosts for demo purposes, so I can run simple projects locally in a cross-site scenario to ensure that I do get different behavior, get the behavior. So as I said, I hope my intention was to give you a crystal ball and a list of rules. This is what will happen, but the more I research this, the more questions I have. Okay, sounds like that it. I'll be around for questions afterwards. So otherwise, thank you for attending.